welcome back. Today we're going to be talking about section 2.7, compound inequalities. So now last section we talked about simple inequalities, where we were graphing something like just x is less than or equal to -2. We went ahead and graphed that within a closed circle on -t, shading down to the left. Okay, now when we deal with compound inequalities, the word compound means something composed of like two or more parts. Now we're just going to talk about two parts. So now we're not going to just graph one inequality on our number line. We're going to graph, in this case, two inequalities on a particular number line. Now there's two different types of compound inequalities. Okay, there's an or inequality, and then there's an and inequality. Okay, so let's look at my left type, which is an or inequality. Okay, so if I have an or inequality, the word or means either or, right? So if I have a value, it could either be true for x is less than -2, or it can be true for x is greater than 3. Okay, good. So now, when we talk about or inequalities, okay, we talk about or inequalities, I think these are the simpler ones because all we're doing is going to graph each individual inequality. So if I have x is less than or equal to -2, I'm going to do the same thing like I did in the last chapter. So if I was going to graph that, it's going to be a closed circle because it's less than or equal to on -2. Something like that. And I'm talking about all my x values that are less than, right? This is pointing left. So I'm talking about all of my values less than -2, right? Good. Now, so I graphed that one. Check. Now I want to go ahead and graph my other one, which is x is greater than 3. So in this case, I'm going to go ahead and look at the value of 3. Okay, and it's going to be open a closed circle. It's going to be an open circle because it's just greater than, not greater than or equal to. Now, I'm talking about all my x values that are greater than 3. So I'm talking about everything to the right. So if you're looking at my inequality symbol, it's pointing down to the right. I'm going to shade down to my right. All right, cool. Now, when we have or inequalities, they're always going to shade in opposite directions, okay? Usually almost always going to shade into opposite directions. So when I think about or inequalities, I want to think about a boat oar. So I want to think about a boat oar. I'm going to think about if I had a boat here, like such. If I had a boat here, okay, I have my oars going outside. Okay, they're my kind of boat oars going outside. It's gonna make the boat move. All right, so if you want to think of something like that, to always remember that or inequalities are always going in opposite directions. Okay, cool. Now, if I talk about and inequalities, okay, and inequalities, it's almost the opposite of an or. Okay, so they're really not going to always go outside. They're always going to go into each other. Okay, so now. Same thing, I want to go ahead and graph x is greater than -1. So I'm going to have an open circle on -1, okay, because it's just greater than. Good. Now I'm talking about all my x values that are greater than. Okay, so greater than, I'm talking about all of these values, right? All of these values. Okay, good. Now, I'm going to be talking about my other one, which is x is less than or equal to 4. So if I'm going to go, I'm going to put a closed circle on 4, and I'm talking about all my x values that are less than. So I'm going to be going into this direction, right? Okay, good. Now, what you have to understand is for and inequalities, the word and means both, right? So for this inequality to be true, my value has to be greater than -1, okay, but less than -4, or sorry, +4, okay? So really, For this inequality, for an and inequality, it is where these two lines overlap, which is right in the middle. There. Right in the middle. Right in the middle there. Okay, so now, if I was talking about just in the middle, I can't use anything there, and I can't use anything there. So I'm just talking about in the middle. Okay, so almost like, this kind of looks like if you're talking about a visual of this type, it almost looks like a barbell. Almost looks like a barbell in this case. You think of it like that. But an and inequality is always going to be something that's going to go into each other. Something between those two, either closed circles or open circle, closed circle, or something of that combination. All right, cool. Now let's go through a harder type of example. So I'm going to go through a harder type of example. I want to talk about just solving. Okay, so I'm going to do the same thing for an OR problem. Okay, so I know that my arrows are going to go in opposite directions, but now, different from my prior example, this was already solved for, right? But now I just have to solve. So you're just going to solve each of them individually. Okay, so if I'm just looking at my left type right here, okay, first thing I want to do is isolate the x. So I'm going to subtract 5 from both sides. I'm going to have 2x is less than or equal to -1 minus 5 is -6. Last step, divide by 2, divide by 2, and I'm left with x is less than or equal to -6 divided by 2 is -3. Now remember, you're only flipping the sign if you're dividing by the negative. If you know there's a negative on this side, it's okay, but the negative didn't cross that symbol, so we're not going to switch it. Okay, cool. So if I'm going to go ahead and graph that, I'm going to go ahead and put a -3. I'm going to put a closed circle on -3. So closed circle on -3. And I'm going to shade down to the left. Okay, because I'm talking about all of my x values that are less than -3. Now we're going to just go ahead and solve for the second inequality, which is, actually I want to use a different color, which is 4 minus 3x is less than 1. So if I go ahead and solve that one, it's going to look like, choose a different color. So I want to subtract 4 from both sides, subtract 4 from both sides. Okay, so I'm going to have -3x is less than 1 minus 3 is -3. Okay, and I want to divide both sides by -3. Now this is where we have to remember, if you divide both sides by negative, okay, -3 divided by -3 is going to cancel out. I'm left with x. Okay, now if I divide by a negative, I have to switch the sign. Okay, switch the sign. -3 divided by -3 is just 1. Okay, so now that's my second inequality. I'm going to go ahead and graph. So I'm going to go ahead and put an open circle on 1. I'm going to shade down to the right. Something like that. Okay, cool. So now that's just my OR inequality. So the same thing, but now I just had to solve for each. Okay, just remember they're always going to go in opposite directions. Good, now, if I just look at number 4, it looks different than what I originally gave you, right? Now, an inequality can have an and word attached, or it could look like something like number 4, where you have 2 inequalities with your x somewhere in the middle of those inequalities. Now, when we get into practice problems to decipher whether you're solving for an or an and problem, okay, the or inequalities are always going to have the word or. Okay, so that's easy. So if they don't have an or, it's going to be an and. Okay, now, if you're looking at 5 is less than 3 plus 2x is less than 13, okay, you're going to solve this as in if they were two separate inequalities. So if I just eliminated 5 is less than, right, and I have 3 plus 2x is less than 13, what would you do first? First thing I would do would be subtract 3, right? Because I want to take that 3 and move it across the inequality. Okay, good. Now, if you take the other side and eliminate it, eliminate that and eliminate the 13, you have 5 is less than 3 plus 2x. What's the first thing you would do? Subtract 3, okay, from both sides to get rid of that 3. So essentially, you're doing the same thing to both sides. So what you're going to do is subtract 3 from everything. So you're going to subtract 3 from the middle, subtract 3 from the left, subtract 3 from the right. Now when you simplify, 5 minus 3 is 2, is less than, 3 minus 3 cancels out, and you're left with 2x in the middle, is less than, 13 minus 3 is 10. Good. Now, the same thing, okay? If you just had 2x is less than 10, last thing you would do is divide both sides by 2. Or, if your 2 is less than 2x, the last thing you would do is divide by 2 from both sides. So you're going to do the same thing, but you're going to divide 2 by the middle, by the left, and by the right. So when you go ahead and simplify, 2 divided by 2 is 1. We're going to write less than. 2 divided by 2 is 1x. Okay, good. Is less than, that should have been less than or equal to, is less than 10 divided by 2 is 5. Okay, cool. Now, I don't know why that looks like that. Five. Awesome. So now when I go ahead and graph, I'm going to have, this is a little bit different, okay? The simplest way I could say is that you know that it's going to be an and. So you know that it's going to look something like that, right? They're going to be going into each other. Now, that could be a closed circle, that could be an open circle, or vice versa. They both could be open, okay? But you know that they're going to be shaded in the middle. So now, as long as your lower value is on your left and your greater value is on your right, which it is, you're just going to go ahead and drop those on the number line. So I want a closed circle, right, on the value of 1. I'm going to draw a closed circle on the value of 1 because that's less than or equal to. Then I want an open circle on the value of 5 because the 5 is associated with just a less than, or sorry, that is, yes, so that's x is less than 5. Very good. So now, if I know it's an and, I want to shade in the middle, so I'm going to just shade in the middle like such. Like such. Okay. And then that is going to be my answer. Okay, so that's an and inequality. So I showed you an or, I showed you an and. Okay, the word and could be shown, or it could look something like number 4, where you have x in the middle with 2 inequalities, or you can have an or inequality that states the word or. Okay, good. Now, I'm going to give you a money problem. Good luck. Try your best. Call me over. Just remember, is it an or is it an and inequality? What should the graph look like? Solve. And call me over. All right, good luck.